Electricity 6, potential dividers. Now, a potential divider is basically a couple of resistors in series. What will be the voltage across each of these resistors? There are different ways that you can work it out. Basically, it's going to be 2 volts and 4 volts. 2 volts across the 100 ohms and 4 volts across the 200 ohms. Now, we can justify that. The total resistance of the circuit is 300 ohms, so the current is going to be 0.02 amps. So you can do V equals IR for each resistor, and you get 2 volts and 4 volts. Okay, basically, in a series circuit, the bigger the resistor, the bigger the share of the voltage it gets. And if the resistance is twice as big as the other one, it gets twice as much voltage. The ratio of the voltages is equal to the ratio of the resistors. There is a more complicated equation that you can use, this potential divider equation, but just doing it by ratios is usually the easiest way. And it's called a potential divider circuit because the potential difference is divided between them, it's shared between them. This is a thermistor. And a thermistor, you should know from GCSE, its resistance varies with temperature. On our course, we'll only ever do NTC, negative temperature coefficient thermistors, and that basically their resistance gets less when they get hotter. Why does it get less? Well, it's made of a material called a semiconductor, and what happens in the semiconductor is that when it gets hot, the number of charge carriers which can actually move through the conductor increases. So if there's more mobile charge carriers, then the resistance gets less. Remember that for metals, it's the opposite. For a metal, when it gets hotter, its resistance gets bigger. For a thermistor, when it gets hotter, its resistance gets less. Now, what we can do with our thermistor is put it in a potential divider circuit. I've put a 100 ohm resistor and a thermistor in series in a potential divider. Now, what will happen to the voltmeter reading if the thermistor gets hotter, if its temperature increases? And the answer is that if the temperature increases, the resistance of the thermistor will get less, so the fixed resistor gets a bigger share of the voltage, so the voltmeter reading gets bigger. And what we've made here is we've made a temperature sensor. You know, if the temperature increases, then the voltmeter reading goes up. And so the reading on the voltmeter gives us an indication of temperature. You might get a graph that looks something like this. And this is the voltage, the voltmeter reading, if you like, against temperature. And as I said, if it gets hotter, then the voltmeter reading goes up. And so this is my temperature sensor. The sensitivity of a device is equal to the change in output for a given change in input. Like for a certain change in temperature, how much does the voltage output change? Delta V over delta T. Looking at this graph, you should appreciate that the sensitivity of this device changes. Early on the graph is steeper, and that tells me that between 0 and 30 degrees, it's more sensitive than it is between 40 and 70 degrees. Calculate its sensitivity between 0 and 20 degrees. Well, that's going to be, below 20, its sensitivity is going to be 4.2 minus 3 divided by 20, which is 60 millivolts per degree centigrade. And not just thermistors, but there's lots of things, lots of components you can use to make useful devices. For example, this is an LDR, which is a light-dependent resistor, another component you should recognize from GCSE, and its resistance gets less when light shines on it. Its resistance decreases with light intensity, and if I swapped my thermistor for one of these, then I've got a light sensor. I shine light on it, and the voltmeter reading goes up.